Hey, Honors Algebra 2, we are back, and today we're going to be looking at solving log equations. In the same chapter, actually chapter 7, section 4, it also includes inequalities, but you know what? We're not doing them. So if we were face-to-face in class, we would be. But since we are making do with the best we can right now, we're going to do solving equations with logs, and then later next week we're going to be talking about properties of logarithms. So if you would, you can open up your book to page 478, because that's where we're going to be, and I will go through the examples, even though I will not do the examples that are in the book. That'll give you an extra example, but I will do a problem like that. So we will start out by doing our instructions. We'll just say solve log equations. And again, if you are in your book, we are on page 478. And this is just building on yesterday's lesson where we had log expressions and we created an equation and rewrote it in exponential form based on the definition of a log. So just to kind of remind you of the definition of a log, it's something like this, that the log base b of x equals y if and only if, which means it has to work both ways. If and only if b to the y equals x. And this way you can really see where everybody goes. Here's base b, here's base b, here is the log value. The log value in log form ends up being the exponent value in exponent form. And then this x over here in exponent form becomes what we call the argument in log form, the thing that you take the log of. So we're basing today's lesson on the definition of a logarithm. And we'll just get right to our examples. The first example looks something like this: log base 9 of 3/2. Wrong. Oh man, well, gonna have lots of mistakes. It's okay. Log base 9 of x equals 3/2. Now you see how this is a little different than what we did in our first lesson. In our first lesson, these two, we knew the base and we knew the argument, but we didn't know the log value. So now our unknown has changed positions. We don't know the argument. We know the base. So essentially, how do we think about logarithms? Well, we think about exponents in reverse. So base 9 raised to the 3/2 equals what number? That's what it's asking us. So based on the definition of a log, to solve this, we got to get the argument. To get to the variable, we got to get the argument out and to be solved for the variable. So good news, we can do that by rewriting as an exponential function. Okay. My kids in the past have called this exponentiating. Got to exponentiate it. Okay, let's exponentiate it. So we'll say base 9 raised to the 3/2 power equals x. Look at there, fractions, everyone's favorite. So let's have a quick reminder. This isn't just 9 cubed, okay? It's 9 to the 3/2, and of course 3/2 is 1.5 power. How do we think about this? Well, we got to remember rational exponents. When we have a rational exponent, and you will have some of these in this lesson, when you have a rational exponent, let's say you base up here, you've got a base raised to a fraction. So you've got a numerator and a denominator in the fraction. The numerator tells you the power that you raise the base to, and the denominator tells you the root that you take. And really, this isn't any different than any other exponent, but we're used to seeing exponents be whole numbers. Well, of course, what is the denominator of every whole number? Well, it's 1. And so the first root of something is just itself. So let's think about that. And the question becomes, well, hey, this is an order of operation problem. Does it matter if I do the numerator first or the denominator? I mean, which do you do first on a fraction power? And the answer is no, it doesn't matter. You do the one that makes sense to you, but I would encourage you to consider doing the root first, because you'll be able to do that one in your head most of the time. Not always, but most of the time. So this is the square root of 9. So really what we're going to do is we're going to say, hey, I need the square root of 9, and then I'm going to cube it, because 1/2 times 3 is 3/2. We've just decomposed the fraction. This is how you can think about it. So the square root of 9 is 3. So now we're going to replace the square root of 9 with 3, since it is the same, and 3 to the 3rd power is 27, so x is 27. All right, so kind of let's go back and see what we did. How is this different than the expressions we looked at in the first lesson? Well, we now have equations, and our variable is not going to be over here. Our variable is going to be over here in the argument. So again, we will use the definition of log base b of x equals y, if and only if b to the y equals x. So the argument and the log value change place. The base is still the base, right? And think about it, that's what happens in inverse functions. The domain and range switch places. Well, logs and exponents are inverse functions, and so that's what's going to happen. The domain and range are going to switch. So we're given a log function. We rewrite it as an exponential. Doggone, we got this fraction in the exponent spot. We're not going to worry, because we remember, hey, the numerator is the power and the denominator is the root. Take the root first if you can. Or if you have your handy dandy calculator, you can type in 9 to the 3/2 power. But you'll get an answer and won't know where it came from. So this is the y, and you know we're all about the y. Okay? If you need to press pause, go ahead. I'm going to go on and do a second example, because I think a fraction warrants that. So I'm just going to change the page. And we'll go right into example 1b. And our instructions are still going to be the same. It's still going to say solve. Okay, solve. So this time we have the log base 16 of x equals 5/2. So again, where is our unknown? It is in the argument. I don't know what log base 16 of x, I don't know. I know, so 16 to the 5/2 power is what number? That's what it's asking. I can rewrite this based on the definition. So we're going to exponentiate, if you want to say that, or rewrite as an exponent. So when I do that, I have base 16, and then the log value in log form becomes the exponent in exponent form. And then the argument becomes the value over here of what the base raised to the exponent is. So 16 to the 5/2 power equals x. And again, this is a rational exponent. The numerator gives us the power. The denominator gives us the root. So I'll just ask you, this is going to be a big number, but do we know what the 1/2 power of 16 is? Don't we know what the square root of 16 is? Well, sure, the square root of 16 is 4. So now we have what? 4 to the 5th power. Now, I don't know that one off the top of my head. We can think 4 squared is 16, 4 cubed is 64, and after that, I don't remember. So we'll go to the handy dandy calculator here. And let's say 4 to the 5th power, and we get 1024. So x equals 1024. Alrighty. So about a third of your problems are like that, where your variable is in the argument spot. Again, what can you do? You can rewrite it as an exponent and then break it down. Take the root of the power first, if necessary, and then use the numerator. If you need to use your calculator, that's fine. Alrighty, so that is example 1 of solving log equations. And I hope that you can get that down because now we've got a second example, but we'll have a different video for that. So stay tuned because there's more fun to come. Maybe. It's okay. I'm not upset.